This is the short version of practice problem number 2 from lesson 3, grid moves, and unit 1, rigid transformations and congruence. And in this problem, you're given this triangle ABC, and you're asked to draw a rotation of the triangle, so rotation anywhere you want on this grid, a translation of the triangle, and a reflection of that same triangle. For the rotation, I chose the center of rotation. I just put that center right here, and then I put each point and its corresponding point on a circle so I could see that rotation. I rotated this figure 90 degrees, so C to C prime. So here's the circle for A. And here's the 90-degree rotation. So if I draw a 90-degree angle from the center of rotation to A, and then the center of rotation to A prime, the corresponding point, this forms a 90-degree angle. Now it's a little bit hard to see. So what you can do is use a counting strategy to confirm that that is a 90-degree angle. So if I start here at the center rotation and count 1 unit to the left and then 3 units up vertically, 1, 2, 3, I end up here at A. So then if I rotate this arrow 90 degrees to right here, and so count vertically that 1 unit and then count to the right the 3 units, 1, 2, 3, I end up at the corresponding point for A. So if I do the same thing for B, so here's B on its circle, and here's the A circle, and the B circle is a concentric circle with the center the same for both circles. And then if I rotate B around the center of rotation 90 degrees, it ends up here. So now I can use this counting strategy once again. So I'm going to start at the center rotation and count vertically 2 units, 1, 2, and horizontally 1 unit. Now if I rotate this arrow 90 degrees to right here, I'm going to count horizontally now 2 units, 1, 2, and then vertically down 1 unit, and I end up with B. So that's a 90-degree rotation. And C, the same idea. Here's the same circle for C, or a concentric circle for C. Here's A, and here's B. And so now C is going to rotate 90 degrees around the center of rotation. So this is a 90-degree angle, and C ends up down here. And again, using the same counting strategy. So if I count vertically 1, 2, 3, 4, and then horizontally 1, 2, 3, 4, I end up at C. So I'm going to rotate this arrow 90 degrees and count horizontally now 1, 2, 3, 4, and vertically down 1, 2, 3, 4. And so you end up at C, and that confirms it's a 90-degree rotation. Another way to see the rotations is to draw a rectangle and look at the rotation of that rectangle. A little bit easier to see that rotate 90 degrees. So start at the center of rotation and draw a rectangle that connects with point A in this case. And then rotate that rectangle 90 degrees, and then point A ends up here. So it's rotated 90 degrees. Do the same thing with B. Start at the center of rotation and draw a rectangle to B. Then rotate that rectangle 90 degrees, and B ends up here, having rotated 90 degrees. And do the same thing with C. And C, you get a square, which is a special rectangle, so it's okay. So here's the rectangle for C. Start at the center rotation. Here's point C. Draw that square or rectangle, rotate it 90 degrees, and C ends up down here. So here are all 3 points together on the concentric circles. So as each point rotates around its respective circle, the whole figure rotates 90 degrees around the circles. And here's everything together. So this is rotating point A to A prime. This is rotating B to B prime. Rotating C to C prime. Rotating rectangles, you get the same answer. And here are all 3 on the 3 circles together. For the translation in part 2b, a translation means to move this figure to its corresponding image and move every point in the same direction and the same distance. So those are the 2 key points, the same direction and the same distance. So if you look at A moves from A here to its corresponding point in its image. So if you count in this case, so I'm going to count over 2, 1, 2 along the horizontal axis and down 6, 1, 2, 3, 4, 5, 6, and I end up with the corresponding point of A. If I do the same thing for B, it has to be the same if it's a translation. So move over 2 along the horizontal axis and down 6, and for C it's the same. Over 2 along the horizontal axis and down 6 along the vertical axis, and you end up at C, the same thing. So this is a translated image of this figure in 2b. And for the reflection, a reflection means you're going to have a line of reflection, so some line that runs right down the middle between the figure and its reflected image. And the movement is to move at a 90-degree angle or perpendicular to that line of direction and an equal distance, the same distance on the other side. So C moves 1 unit along this diagonal and then 1 unit on the other side to here. B moves the same distance, is perpendicular, forming a 90-degree angle with the line of reflection. So B moves 1.5 units. And so there's that half and then 1 unit on the other side. So B ends up here. And A moves 3 units, 1, 2, 3, and then moves 3 units on the other side, 1, 2, 3. And you connect those points and you have the reflected image of this figure.